Hello and welcome to helpyourmath.com. In this video, this is part 4 of our part 4 series on verifying trigonometric identities. Just to review some strategies to consider when proving trigonometric identities. Choose the complicated side to clean up. If both sides look messy, pick one, see what happens. Apply any of the fundamental identities that we'll talk about on the next slide. That's sine and cosine, cotangent and cosecant, tangent and secant. Convert all terms or factors to sines and or cosines. Look for opportunities to factor, combine fractions, multiply conjugates, etc. Try something. Dead ends can prove insightful too. And also know that there are several ways to prove each identity. So just because I do one way does not mean that that is the only way. Here's the collection of trigonometric identities that we can use. I've gone through these before, so I'm not going to spend too much time on these, but just know these are all on the table. Let's get started. In our first example, we want to prove that these two things equal each other. Which side do we want to work with? I think the left side looks a little bit messier, so we want to get that the left side matches the right side. The first thing I notice is that the right side has just one single denominator, whereas the left side has two. So I might consider getting them to have the same denominator. If I do that, the common denominator here would be cosecant of x times cosine of x. So this is missing our cosine of x, and this is missing our cosecant of x. Okay, so that would give me cosine of x times tangent of x minus sine of x times cosecant of x all over cosecant of x times cosine of x. Okay, I at least have it down to one term, but it looks like we have some cleanup to do. First of all, I know that sine and cosecant are reciprocals of each other, and any number times its reciprocal is equal to 1. So we get the 1 there, which is great. So now we have cosine of x times tangent of x minus 1 over cosecant of x times cosine of x. And if your particular instructor is picky about this and you actually have to show that step, you would show sine of x times 1 over sine of x, and then you would cancel those out. Okay, look, we have the minus 1. How are we going to get that cotangent though? Well, we look a little bit stuck here. So what I might do is take the tangent and the cosecant and write them in terms of sines or cosines. So that would give me, if I did that, I would have cosine of x times tangent is sine of x over cosine of x minus 1. I'm just going to put this one over 1 just so it has a denominator. And then cosecant is 1 over sine of x times cosine of x. And again, I'll put that over 1. What I see here is that the cosines cancel. So there's sine of x minus 1 in the numerator. And here, the denominator would end up as cosine of x over sine of x. Well, cosine of x over sine of x, that's a quotient identity. And that is cotangent of x. And thus we have a match. Hooray! Okay, in our next example, and if you're feeling ready, pause the video, see if you can do this. You definitely know which side you're going to be working with. It's going to be the left side again. So we want to make the left side match secant of b. Let's see, okay. Oh, look at the denominator. The denominator, we have a common factor. So what happens if I factor that out? We get 1 plus sine of beta over, I'm going to factor out that common factor of cosine beta. That's going to leave me with 1 plus sine of beta. Okay, now the numerator and denominator have a common factor, so those become 1s. And I'm left with 1 over cosine of beta, which I can use the reciprocal identity to say 1 over cosine of beta is equivalent to sine of beta, secant of beta, which is what I was trying to show. Oh, that wasn't so bad. That was actually kind of nice. Okay, for our next example, give it a shot. Looking at this one, both sides kind of look messy. I think I want to start on the left side. I looked at the right side. I noticed that it equals cosine squared beta, but then I kind of get stuck from there. So that's good to know that it's cosine squared beta, but it doesn't really help me get closer to the left-hand side. So I think I'm going to start with the left-hand side, is my point. Let's see what happens. So what I'm going to do is I'm going to take this cotangent squared beta and I'm going to rewrite it. So I have sine squared beta over 1, and I'm going to write cotangent squared beta as cosine squared beta over sine squared beta. Aha! It was helpful knowing that I wanted it to be cosine squared beta, because there's my cosine squared beta. Well, I know using the Pythagorean identity that sine squared beta plus cosine squared beta is equal to 1. If I want cosine squared beta, I would subtract sine squared beta from both sides. And that would give me that cosine squared beta is equivalent to 1 minus sine squared beta, which is what we were trying to show. That wasn't so bad, was it? Yay! Okay, for our last example, go ahead and try it on your own. And what I'm going to do is, what I noticed is that for this example, you can actually start with the left and get it to match the right, or start with the right and get it to match the left. So we'll actually look at both, and you can see which one you seem to like better, because maybe that'll help with future trigonometric identities. So first, going from left to right, we have cotangent of b times cosine of b. That's not super helpful because I need them in terms of sine and cosecant, which is the reciprocal of sine. So I'm going to use the quotient property first and rewrite cotangent of b as cosine of b over sine of b. Then I'm just going to put cosine of b over 1. And then I'm going to multiply straight across since we can't simplify. That's going to give me cosine squared of b over sine of b. Okay, so then cosine squared of b, remember in the last example when we had cosine squared of b and we rewrote it using the Pythagorean identity? That's what we want to do here because that's going to get it in terms of sine. So we're going to rewrite it as 1 minus sine squared b over sine of b. Then what we can do is we can distribute the sine of b that's in the denominator to the two terms in the numerator. So that would give me 1 over sine of b minus sine squared b over sine of b. And then the first term, 1 over sine of b, that is cosecant of b. Here we have two factors of cosine of sine b in the numerator and one in the denominator, so one of those will cancel, leaving me with a sine of b in the second term, and voila, we got them to match. Okay, but what about going from the right side to the left side? So how could we do that? Well, if we look at cosecant of b minus sine of b, I notice that the left-hand side has one term, and here we have two. So the first thing I might do is rewrite this as its reciprocal, and that's 1 over sine of b minus sine of b. Now I want to combine these, and one's a fraction, so I'm going to turn them both into a fraction. And then I figure out that the common denominator here is going to be sine of b. This one needs that factor of sine of b, so I'm going to multiply it to both the numerator and denominator. And that's going to give me in the numerator 1 minus sine squared b. In the denominator, I have sine of b. Okay, so now we're going to use that same Pythagorean identity. That same one keeps coming back to haunt us again and again. Cosine squared of b is the same as 1 minus sine squared of b. So I can write this as cosine squared of b over sine of b. Now I might want to think about this as cosine of b times cosine of b. And then take this and write this using the quotient identity, as that would be cotangent of b times cosine of b. And lo and behold, we get back to what we were trying to show. So that one did have a few more steps, but maybe you like that way better. And again, it doesn't matter as long as you show that one side matches the other. That's the whole goal of trigonometric identities. This has been our fourth and final installment of verifying trigonometric identities. Thank you for stopping by.